Welcome to ComputeSplained. If you're ready to dive deep into C++ programming and master its concepts, you're in the right place. Before we get started, make sure to hit that subscribe button so you never miss out on more in-depth tutorials and programming insights. Let's level up your C++ programming skills together.
By this point, we have a good idea of the underlying philosophy behind C++ as well as its differences from C. Now let's turn our attention to the topic of C++ compilers. C++ is what is known as an open programming language, which means that anyone can implement their own compiler for C++. All that matters is how closely the compiler complies with the C++ standard. Consequently, there are compilers for pretty much all popular operating systems and environments. Ideally, every modern compiler ought to adhere to all of the standards specified for the different C++ versions. Now, of course, when a new version of a standard is released, compilers are going to take some time to catch up. In the period while compiler writers are implementing those features, some major gaps might temporarily open up between different compilers. If you'd like to check compiler support for different versions of the standard, there are plenty of online resources, including the URL that you can see on screen now. By and large, once a standard has been out and published for a considerable length of time, most compilers converge on implementing most or all of the features. And then, of course, it's time for the next version of the standard, and the whole cycle begins again. One of the most important C++ compilers is the Microsoft Visual C++ compiler. This is the C and C++ compiler that Microsoft bundles with Visual Studio. Visual Studio 2019 supports C++ 17 features, and Visual Studio 2022 will have full support for all features in C++ 20. As you might imagine, the Visual C++ compiler is generally used on Windows, but it can be used to develop native Linux apps as well. G++ and the other GNU compilers are also extremely important for C and C++. GCC 11 is the version in widespread use currently. It has full support for C++ 17 and almost full support for C++ 20's features. It's primarily used on Linux environments. Clang and Clang++ are also important C++ and C compilers, and these belong within the LLVM project. This is a collection of modular and reusable compiler technologies. LLVM is not an acronym, rather it's the name of the project itself. LLVM core libraries provide both optimizer as well as code generation support, and Clang is an LLVM native compiler. We'll be making extensive use of Clang and Clang++. Clang is the default compiler for Mac OS. We'll be using a combination of Clang with VS Code as an IDE. The Clang compiler architecture makes it easy to add new optimizations. The current version is 13. This too supports C++ 17 entirely and also has almost complete support for C++ 20. Another important compiler is the Intel C++ compiler. This one is heavily used in computationally intensive applications. It has a very high level of performance and provides special support for high-performance threading and parallel computations. It's used heavily in applications that require data parallelism, such as graphics programming. Whichever one of these compilers you happen to be using, you can fully rely on support for something known as the C++ standard library. As its name would suggest, this is a collection of classes and functions, all of which are written in the core language and are a part of the C++ ISO standard. You might recall that some of the principles we earlier discussed spoke about the need to use an up-to-date compiler and not rely too heavily on extensions. In fact, ideally avoid compiler extensions entirely. And the unwritten message there was to stick to the C++ standard library. This is a huge library which has functionality required across applications, for instance, string processing, sorting, searching, and so on. Just to be clear though, the standard library is not quite the same as the standard template library or STL. This can be confusing, especially because the standard library itself provides a lot of generic container implementations and functions to work with these containers. In addition, it has many useful function objects, generic strings, and streams, The standard library also has functionality related to threading, math, strings, and useful algorithms. Also, it specifies the syntax and semantics of generic algorithms and also specifies requirements on the performance of these algorithms. So, any compiler which claims to implement the standard must adhere to these requirements. The standard library is not to be confused with the standard template library or the STL. The C++ standard library is based on the original STL, and that original STL has components for algorithms, containers, functions, and iterators. The STL intentionally makes the algorithms independent of the containers. This reduces their complexity. Even though the STL and the standard library have heavily influenced each other, they are distinct entities. We will be making extensive use of functionality in the standard library as well as in the STL in the demos coming up ahead.